the others also will join. Okay.
Definitely, sir. Yeah.
Yeah, sure.
Good evening, everyone. So this is Srikanth here. So I warmly welcome everyone to the third talk on the Kite webinar platform series. Today we have with us Dr. Krishnamurthy Subramanian, affectionately known as Dr. Subbu to everyone, to deliver his webinar on system thinking and transformation skills. He is the founder and president of SIMS Institute USA, and he has over 4 decades of experience in manufacturing industry, innovation, technology development, and mentoring professionals and companies. He has published several books and author of many publications and patents which are in commercial use. He graduated from Osmania University, India, and obtained his PhD at MIT, USA. He then moved on to serve as the Director of Surface Preparation Technology at Norton Abrasives and later at Saint-Gobain. In his role, he has expanded science and application of grinding processes into many areas such as aerospace, electronics, and semiconductor manufacturing. He also developed process innovations and product innovation through application technology centers in many countries across the globe. He has expanded currently his model for the advancement of professionals and companies through system thinking and transformational skills. He is closely associated with AMTDC since its inception and also serves as one of the advisors. He also serves as advisor, consultant, and mentor across the globe for a number of programs and initiatives. Dr. Subbu is a fellow of ASME and MSME, and he was recently awarded the prestigious Merchant Medal in 2020 for manufacturing excellence. He is committed to the Vedic philosophy and its guidance, the Sarve Jana Sukhino Bhavantu, meaning may everyone and indeed everything exist in peace and harmony. He has learned to understand this storehouse of knowledge, Vedanta, as the diamond hidden in our plain view. It is also to be recognized as emotional intelligence, one of the transformational skills. I welcome you, sir, to start your webinar and engage us.
Thank you, Srikanth. Can you hear me well?
Sure, sir. Yeah.
Okay. And thank you, Professor Babu, Mr. Parao, and many others who are in attendance today. It's really a pleasure today to be able to share my experiences under the theme of system thinking and transformational skills. So what I will try to do is start with a small story, then give you a few personal stories from my own life experience. And as you will see, each experience or story from my personal life builds up in scale and the complexity of the problem involved, but the approach and methodology remains nearly the same. And it's interesting, once you have that framework in mind, it can be used for approaching any problem or any project or any activity, either big or small. We call that the system thinking and transformational skills. First, my story. There is a room inside of which there is a lawyer, there is a priest, and then there is an engineer. All three of them were told that when you open the door and go outside, the whole wide world is available to you. If you're a lawyer, you can enjoy all kinds of things in your professional field. If you're a priest, you can enjoy the joy and privilege of being a priest and helping others. If you're an engineer, especially in the manufacturing engineer, you can participate in the world of global economy, Industry 4.1, IoT, and all the things you can dream of and imagine. But the only thing is, the door has got some mechanism in it. Sometimes it doesn't work well and will trap you. So you have to learn how to make sure you get out of it. But you can have only one try. So the lawyer went to the door. The mechanism did not work. So he had a good life and enjoyed the benefits of all the things. The priest did the same thing, and he had a wonderful life in his own way. Then came the engineer. It could be any one of us in this room, or a good bright young student participating in the internship program. He tried to open the door, and the door opened. So the mechanism did not work. So he could have very well gone out and participated into the world of Industrial 4.0 and all those things. Instead, he got mad, or she got mad, and said, how can a mechanism designed by me and my fellow students and professors not work? So he came back into the room and started fixing it and said, try this door now, it has got to work. So you see, we tend to do the same thing the same way over and over again without realizing we have to think differently depending upon the situation and circumstances. That need to think differently depending upon what the problem is and how to bring together the right resources to make progress is what you call system thinking. And there are some skills that you can codify out of that. Now, I'll share with you a few stories from my own personal experience. First, my master's thesis, it was a collection of how to sense toolware. And in those days, 40, 45 years ago, nearly maybe even 50 now, it's nearly impossible to get all the information. So you have to write to all the faculty, professors, and so forth. And they send reply by mail, you collect it, you Xerox copy it, cut and paste, not cut and paste, literally cut and paste it, and created a report, which took us nearly 12 months to do along with my associate, Stephen Basili. Today, if I wanted to put together a report like that, I can probably do it within 1 month using Google search. In other words, the tools and techniques available in the digital technology enable us to do things much faster and much better, provided we know what we want to do and why we want to do it. Next, my professor gave me this project for my PhD work, and we developed a sensor for cutting tools for drill bits. As you probably know, many of you in the automotive industry, tens or hundreds of drills are used at the same time to make engine blocks and other parts. So any one of them fails, the whole machine has to be stopped. So we developed a method to sense that automatically and put it together. In fact, it was Internet of Things of those days, but no internet except you collected the signal right there and used it to solve the problem. Instead of sending the signal through the internet over long distances and manage the data. We got a patent out of it, so I learned a lot out of it, but unfortunately the project went nowhere because the signal source we are using was nuclear radiation. As soon as you say nuclear, nobody wants to touch it, right? So in other words, even though the professor gave a good project and it was very well done, it is absolutely no use to anybody if it is not also thought through why we want to do this project and for whom it will be useful. In other words, learning that important lesson, that is, don't pick up any project just because it is there to be done, to be funded, but do it because it has some role and purpose for somebody, is part of the system thinking. With all this knowledge and all this experience charged up, I went to Ford Motor Company. They asked me to build a high-speed milling machine. I asked them, why do you want to build a high-speed milling machine? Well, they said at low speeds, ceramic tools are used. They break because of the high chip load. So if you go to high speed, low chip thickness, low force per cutting edge, tools work well and they don't break. So the assumption was the mechanical rupture of the tool was the reason for the ceramic cutting tools to break. So having this experience from my PhD work, I asked, can you show me a tool that is not broken? Because if when you use it, it cannot be broken. When it's broken, it cannot be used. So can you show me a tool, stop it while it's being used to see how it is, why it's not broken? Believe it or not, nobody will give me a zinc cutting tool that was used, that was not broken. Every tool I saw was a used tool but was chipped. So my boss said, why don't you go to the plant and ask them to stop the machine, take a look at it. Because when you are in R&D, it's very easy to say things like that. So naively, I went to the plant. And in the plant manager looked at me like I was somebody from Mars. Who would want to stop $1 million worth of machinery just for some young lad to stop the machine to look at the tools? In other words, to get real data in real manufacturing is far more difficult than to get data for computer-based projects. You can get a download of database, you can work on it to develop solutions and download it and somebody can use it. But that's not the case with manufacturing. You really have to have real data from real floor, so difficult to get. But I stood there for 3 days and in front of his office. He was getting mad. My boss was getting mad. And ultimately, he said, go to the shop floor and see if somebody can help you. So I go to the guy in the shop floor, and the guy is the supervisor of the line. But he says, I'm also the union boss. You are here to improve productivity. I'm not going to help you. So I had to make friends with him, buy tea. I know more about his personal life than anyone will care to know. But you get to know them. That is part of how you build relationship with people who don't want to deal with you the way you want to deal with them. But ultimately, he said, you go to that operator, he will stop the machine. After all this long story, he stopped the machine. We pulled a milling cutter with 44 inserts in it using ceramic cutting tools, cutting edges, for milling the deck surface of an engine block. Now, I'm using all these terms because all these terms are manufacturing terms. If you're not familiar with them, you have to get to know them. But I can't do all of that in one short seminar. But the engine deck surface as was milled, these 44 inserts, we pulled the milling cutter and looked at it. Obviously, none of them was broken. But believe it or not, none of them, they also had cracks in them. But the cracks were not due to mechanical rupture, but due to thermal fatigue. In other words, the assumption that the cutting tools, ceramic tools fail due to mechanical rupture was an assumption, engineering assumption, not validated by the science behind it. So I came back to the lab and asked, is there any ceramic material that will have better fatigue life, thermal fatigue life, even though it may not be as strong in mechanical rupture like a aluminum oxide cutting tool? Lo and behold, a lot of scientists are there ready to give me tools, materials, because they're all struggling. They all have the material, but they have not taken the transition of taking that information to the factory floor and to see the connection. And finally, they gave me a material. We worked out it. It was a silicon nitride based family of cutting tools. Believe it or not, that tool lasted 20 times longer than the previous tool. Essentially, you can put the tool, if you're changing tools every hour, in this case, you can change the tool every shift or once a day. In other words, the problem has completely changed from high speed milling operations to high productivity operations. That is how the science problem has been solved. Now the engineering is under what range, what constraints will be applied, and that is selected carefully, about 50 applications. In next 6 months, with a team of people, we implemented that. We got the patent, we got the IR 100 award. The whole project was done in 18 months. So in other words, any project that requires to be solved has a scientific problem behind it that has to be understood. The engineering issues which are relevant to the application of the science that has to be understood. And finally, a strategic thinking or management or how to pull it all together. So with all this experience now, I have moved on to another project and a few other things. And then an opportunity came along where International Harvester Company, 100-year-old company, now if it had survived, it will be 140, 150-year-old, but it didn't survive. I'll tell you that story now. So I went to that company because they were hiring all kinds of top people, talent from all over the United States to build their R&D center because they wanted to have global competitive advantage. They're being beaten up by Komatsu from Japan and Dresser Industries from Germany. And it's a 100-year-old brick and mortar company. So they had to go become innovative, do research, just like we are trying to do at AMTDC. Unfortunately, fortunately, they gave me a project to dry corn because it's a harvester, where it's a company that makes some machinery for agricultural equipment. So they wanted to dry corn while they were harvesting, so that the farmers can store the corn longer time without having to sell it in a short time to the people who dry and store it. So it will be better economics for the farmers. So we came up with a method of drying corn while you are harvesting it. Again, the idea was proven in about 6 months of time. So I was all excited, went to see my boss on a Friday evening and said, "Sir, we licked the problem. We got it. Now we are ready to go to build a prototype and we can go commercial." He said, "Subbu, wait till Monday morning. We have a big meeting." I said, "Why he's not so excited?" The amount of excitement I had as a scientist, he didn't seem to show, even though previously he would have been very excited. But Monday morning we go, we have a big meeting. The CEO of the company comes and says, "We have been fighting this competition with the global industry, global companies. Our cost is too high, expecting a strike because I wanted to reduce the labor cost. I wanted to build up a lot of inventory, but in the process, we have a lot of loan with high interest rate, but the people are not buying heavy capital equipment because the interest rate is high. So we are not able to maintain the operations, cash flow is going down, and so we have to shut down the whole company and we are going bankrupt. Sorry for all the bright people who came from all over the world. You get 2 weeks notice and you go home." So you see, no matter how good a scientist you are and how good an engineer you are, it serves no purpose unless you also have the strategic understanding of where the company is going, where the project is going, where the country is going, and how to contribute to it in alignment with what the requirements of the organization, the company, and the country are. So you can see slowly it's building up. That is, science, engineering, and management are interdependent. They are not three different silos. You have to keep them in mind, and keeping that as part of the big picture is what we call a system thinking. So with that, I went to Norton Abrasives. I told them, and I got a job. But once you go from one job to another, you cannot start where you started. You have to go down. So again, I went back to R&D level, project engineering level, developed something. And this gentleman, his name was Mr. Stan Huffman. He was coming, he had a good acumen for machine tools and machinery, but didn't have a lot of academic education. He wanted to build a multi-axis CNC machine for grinding gears and complex cutting tools and things like that. So we had to design something that will make the grinding wheels work better. In other words, in manufacturing, the output is not always the product that you sell or the process that you make to make the product, but also the application of the product. So the innovation in manufacturing can be through the product technology, through process technology, through applications technology. So I took the third path and developed something, and I told him, "You can use this on your machine to use our grinding wheels better." I gave him all the theories, graphs, and everything, very excited. He tapped on my shoulder, "Subbu, don't tell me all this technical stuff. Build something in a cube about 15 centimeter by 15 centimeter, 15 centimeter, put it on my machine, make it work, do my job, let me go build my machine, and you go do your research." In other words, you have to think what's called end-to-end innovation. It's not sufficient to think of research. It's not sufficient to build in terms of all the engineering details, but you have to make it work in the real life and make it only then whatever you did at the science level, at the engineering level, and the strategy level is useful. We call it end-to-end innovation. In fact, if you think about AMTDC, every project that they have taken so far has ended up with a commercial product that some company is able to use. It's not just a pie in the sky, but it's truly leading from idea to development to commercial implementation. Okay, with all these things, now we moved on to bigger things. I developed some real fundamental understanding. When I say I'm really talking about the team of people who work together. There's no single I in any of these jobs or careers. So we developed fundamental understanding of science of grinding ceramics. And if I go to a conference to present this, before me will be a professor from some university or some other researcher who will say, "Don't grind ceramics, it causes brittle fracture, so it'll not no good." But I had in my hand ceramic springs that you could grind helical grooves, and you can collapse it like a metal spring. You can bounce it off of the floor like a steel spring, it will not break. But that is the beauty and joy of a scientist, to do something that is unique that nobody else can understand why. But then you have to translate it to engineering and real life applications. But how can I do that if everybody in front of me is saying, don't do this because it's not going to be a good way to do it? And in order to do that at this level, you have to understand any manufacturing system or solution always involves the right machinery, right tooling, right operational parameters, and right so many other things that have to come together. So without the right machinery, I could not do that. I was coming from only one part of the system, the grinding wheels. So I went to a machine tool conference and I told them, this is what we can do, but I can't do anything without your machinery. But I can't buy all your machinery. Then they said, what will happen if we give you machinery free of charge? Can you guarantee us that 6 to 9 months from now, whatever machine we give, you will sell it for new applications? That will be new business for us, new application for you. Everybody is a win-win. I said, sure. So before I left the meeting, I had $2 million worth of machinery, 4 machines each worth $500,000, which I could never have bought from a brick and mortar company that's also struggling in the global economy. But with this, I went to the company and said, I need a place to put it. So to make the long story short, we started the Ceramic Machining Technology Center. And in 8 to 10 months, we sold all the 4 machines for 4 different applications. So at this time, I went to IBM San Jose. Now you can also see the complexity and the partners involved is also increasing. This is what we call ecosystem development. You cannot do it only by yourself as one company or one industry or one project team within a university. You have to really build the teams together with the right, but all of them working on the same science. Same, because science is nearly the seed. That's the same. Engineering and the management come together at different pathways. So this took me to the next level. I went to IBM and we explained this to them, and they said, wait a minute, we are trying to commercialize thin film head technology, which is a 3 millimeter by 3 millimeter square disc heads, which put information, take information out of the disk. That is different from the old tape heads, which you might have seen in your cassette tapes and recorders and things like that, which are much larger ferrite heads. But these are aluminum oxide, titanium carbide tipped thin film heads. We need to develop this at a much faster rate, at a much higher productivity, much higher reliability. If you do that, we got a new business. If you do that, you got a new business and all kinds of things. So, and Mr. Dick Satterfield, a gentleman there, he and I and a few others became a team. We didn't have a formal MOU or agreement, but there was an intellectual, morally bound team to develop some solution to make it happen. And at the end of the story is we developed the solution, commercialized. IBM was the first to launch hard disk drives. Today, millions of such hard disk drives are used by Google in their farms for data storage. When you say you're putting data in your cloud, you're really not putting in your cloud, but you're putting them in these data storage facilities of Google and Amazon and Snowflake and other companies. So, but even so, like that, many other applications went on. So, to bring my story to a closure, you can see that every project involves understanding what is it you want to do, the technical output, why you want to do it, which is the system output, how are you going to do it, what is the scientific reasoning behind the transformation, and what are the inputs that go into it. And the scale and size and the complexity of the input will vary depending upon the size of the project, but the transformation of the science or the technical output and then the system output will also change, but the transformation will remain the same. So as a research and an R&D center, you can identify the transformation, develop it and demonstrate the technical output and system output, then hand it off to somebody else who will do it in a larger scale and finally at the larger scale, finally at the national level and so forth. So this approach, this methodology is what we call as system thinking. So far I've been only speaking, so it has all been acoustics. So to make it a little bit more visual, I'll present to you a few slides and then wrap up my presentation in another 10 minutes or so. Are you able to see my slide now?
Yes, sir, it is loading.
Okay, so I'm going to show you in a slideshow mode if I can. So if I ask, so any problem can be thought of as what is 2 plus 2? So those of you in the audience, if you want, you can put your answers in this chat box or make a mental note of what your answer is. So how many of you said it is 4? If you did, then many of you missed the point I was trying to say for the last 20 minutes or so. Because it is 4, that's no-brainer. Anybody should know that. But what does each 2 stand for? We have to ask a question. Supposing I tell you it's oranges and apples and banana and pineapple, then what is 4? It will be completely different from what you told me as 4 in the beginning. Now, so you have to ask, what is it that I want out of these apple and oranges and pineapple and banana? And why am I interested in that? In the last talk, Mr. Appara mentioned about Simon Sinek, and he says, in fact, his whole consulting is based on ask the question why. But what I would like to suggest to you is it's not only important to ask the question why, but how to ask the question why. What is the relevance of why? Who are the stakeholders involved? What is the benefit for them? And that is part of the system thinking and transformational skills. Supposing I told you it could be any one of these outputs. It could be a fruit arrangement, a fruit plate, or on the side I had an ice cream, so I can make a fruit salad. Now you've got a 2 plus 2 equals new solutions and rewards. So this is the very fundamental of the system thinking. You can also make it in a simpler way as to say 2 plus 2 equals what? What are the inputs going into the first 2? What are the inputs going into the next 2? What does the transformer plus really mean? That is really the science behind it. Many a time when we teach courses or subject in colleges, we just teach lots and lots of arbitrary information which is already available in the Google. What we should be really teaching is the plus part of the course. What is it that you are trying to teach the students to put that information together to understand the transformation of scientific phenomena that you are trying to exploit within that subject? So, how do you add the first 2 with the next 2? All at once, little bit at a time, in some new method or new way? These are all part of the scientific thinking. The technical then will be, what do I want when the plus is finished? Why do I want that? And who else needs that? Again, most of the time we think of goals and objectives from the management point of view. What does the management want? But who is the management at the end of the day? So management is part of the system. They are providing input in terms of guidance and direction. They're providing investment. They are providing structure. Other than that, management is only part of the system. The workers are also part of the system. They say customers is a king, but customer is the king means why is not the boss not the king? Why is not the investor not the king? Customer is the king only so long as they're thought of as part of the input to the system because their need we are trying to satisfy. So we have to, second thing we have to understand is to make the distinction between what a task and what a system. Anything you do, that something you're doing in response to somebody say, go do this, what you call plug and play is a task. In fact, digital technology increasingly is becoming more and more to move you away from system thinking to task-oriented activity. In fact, a lot of people working on digital technology are creating system-level solutions to make you become task level players. So you have to understand that. So you have to become a system thinkers to use the digital technology. I'm not saying become opposed to or uh, in contest to the digital technology, but use the digital technology, but as a system thinker, but don't fall into the trap of becoming a task-oriented individual, because then you are going to get only the Google salary and the Walmart salaries or McDonald's salaries if you're an intern going to college, or Walmart projects and Google McDonald projects if you're a professor or an engineer in a company. You have to really be organized, work system thinking. Prior to engaging it, ask what needs to be done, why am I doing this? The sum has to be larger than mere collection of tasks. Everyone takes ownership or responsibility all the time. It's not a question of just coming in and going out. Results or benefits are earned by everyone. Results or benefits are shared by everyone. Now, these things are not philosophic or just hypothetical. These are real. If I develop a new application where I develop a new abrasive tool or a cutting tool, I cannot expect to grow that business unless I also see a machine tool company growing its business, or a coolant company growing its business, or a customer growing their business, or the engineers in all these companies also succeeding along with me. So, in other words, results or benefits were shared by everyone, the stakeholders. So, once you identify the upfront, then we'll be able to move forward successfully. Little bit more detail on technical output versus system output. For example, if you take a course, that's a task, but the knowledge and expertise you gain out of that will be the system output. What grade did I get will be the technical output. What capability or professional skill I gained will be the system output. Project report at the end of internship each of you are doing will be a technical output, or the outcome of the project will be the system output. Similarly, we build a test bed will be a technical output. What are the results that came out of it? What are we validating in the scientific concepts using the test bed will be the system output. I get an invention and I got a patent will be a technical output. What are the new outcomes will be the system output. Product of any company is truly a technical output, or the performance and the value and use of the product is a system output. Or is the process is a technical output, or the solution or the value addition will be the system output. Similarly, use will be supposing I take a car and I drive. That is just a use of the car. But what is the benefits or value realized will be the system output. So now you can go on to another dimension of system thinking. That is, how much value am I adding? Because at the end of the day, all of us as professionals add value through information, paper, pencil, computer, PowerPoint, Google search, whatever it is, physical work, factory floor, assembly, testing, conversation, meeting, all kinds of things, but then also knowledge and its use. But the maximum value is added by any professional is only through knowledge and its use. That we call as the value added score. What percentage of your time in any, for example, this seminar, you're spending your time, that is your physical work. I'm talking to you, that's information work. What is the knowledge that we shared between me and you that will be useful to you so you can do something with it? That will be the value added score of this seminar. Now, this is a little bit more complex, like everything else. So now you can think of a system at a higher level where every manufacturing process involves a hardware, software, application, and specifications. If I think of a computer project, if I think of a machining process, a manufacturing process, it involves machine, tooling, work, and parameters. And we do some transformation, get something out of it, and why. In fact, if you look at all the projects done at AMTDC, you can outline them like this. In one project, it may be how do you manage the thermal error compensation. That will be the science behind the project to achieve higher precision, so leading to new machine tool for a machine tool company. In other case, it may be developing a robot so that the mechanism, the science of designing the robot for certain specifications, which can be replicated for any number of other robotic applications. Then in that particular case, it may be a low-cost robot, but making it available as a teaching tool may be your system output. So in every one of the case, there is a science, there's engineering and management. And by the way, management itself has got two components, operations and strategy. So integrating the science, engineering, and management is truly technology. By the way, this is one of my pet peeves. Whenever you go and read any book or any publication or hear talks, technology, when I say high-tech company, it is not a Kirloskar or Mahindra or a TVS or something like that. Instead, it will be Satyam Industries or a TCS or something. Why is that? Because we have begun to believe that only the IT or a digital technology is a technology. That is because we have not understood the common language of what technology really means, which is integration of science, engineering, and management. So the government of India and others see this in their own way, but they don't articulate it in this language. So they want AMTDC, they want innovation centers, they want internships, they want high technology workforce. But what they really are saying is develop people skilled in the science, engineering, and management of machinery and machine tool development that will enhance the industry for heavy industries or for agricultural sector or any kind of things like that. So you can take that to higher level, like I showed you in my thin film technology model. So now you are looking at investment, expenses, need, and constraints. Again, the science is the same. The management will be what is the operation strategy. By the way, I think next week you'll be hearing from Mrs. Navina Swami about the how to distinguish between operations aspect of a management from the strategic aspects of the management. So then there are three levels of system thinking: awareness, analysis, and synthesis. I won't spend much time on it today, but you can read to them later on, or we can have more discussion later on. So if you think then innovation is what our goal is, there are two dimensions. One is system thinking, the other is end-to-end innovation. You can achieve end-to-end innovation through brute force or through the methodology I gave you. The methodology I have given today can be used for any problem, any project, whereas if you do it through brute force, you did it once, then you don't know how to repeat it. And what we are trying to do in the internship program, as best as I can understand, is to educate students through specific projects to become system thinkers and to push towards end-to-end innovation at the basic level. Maybe one or few projects may end up to the very high level of synthesis and implementation of use, but that is unrealistic. But if you do, the value of that will be in some arbitrary scale 81 compared to 1. Today, lots of students are even outside of this in a task-oriented regime. A lot of engineers are in the task-oriented sphere. We're pulling them. They're also doing things because they're task-oriented. They neither care for system thinking nor care for end-to-end innovation. Now we are trying to pull them into this platform through specific projects, and mentors with the knowledge and experience are able to guide them towards innovation. And hopefully they can also adapt some of these tools. By the way, whatever I'm talking about may be the same that all the mentors will know in their own way, except I'm articulating in a particular way. It is articulated slightly differently by Mr. Apparao in the last talk. It was articulated slightly more differently by the speaker before, but the thought is nearly the same. That is, the solution is much larger than the collection of tasks. So don't get mired in a set of tasks and be only for your own personal self-interest, but get out of that to into larger common good and figure out how to put the tasks together to look at the big picture so that you're able to see the picture as a whole rather than pixels on your TV screen. So that brings us to the 7 transformational skills. First is developing a common language. Second is 3-dimensional view of core capabilities. I've repeatedly said science, engineering, and management. That is at the professional level. There are certain things at the individual level, certain things at a higher level, which will go into at a later stage. With all these things, you integrate the knowledge in all this. So don't treat science, engineering, and management as 3 silos. Then emphasis on science and mobile diagnostics. All we talk about IoT is nothing more than mobile diagnostics. That is, the diagnostic tools are wherever they are, the data can be accessed somewhere else. But if you don't emphasize on the science of the process, science of the product, or science of the use of the product, IoT by itself is arbitrary and irrelevant and immaterial. Then we talked about end-to-end innovation. Then we talked about building ecosystem, that is bringing all the right partners together. Like AMTDC today is an ecosystem involving companies who are interested in developing innovative projects. Government of India went into some fund, IIT Madras with the resources, students and the projects, internship programs, mentors, all of them focused on common interest in end-to-end innovation with guidance and management through people like Professor Subbu, Mr. Srikanth, Vairamuthu, and others. And the last one is emotional intelligence. Now, each one of these will take a seminar by itself, so we are not going to do it today. But I go back to the final question, earlier question, that is, you have to start everything by asking why, but how to ask a why itself is a knowledge by itself. We will call that the emotional intelligence. So you can gain academic knowledge in a university. You can get industry-specific knowledge. You also can have transformational skills, how to get away from task-oriented plug-and-play mode to new solutions, to system thinking and transformational skills. But these three things have to be kind of developed in parallel. I think the director of IIT Madras in one of the talks mentioned that the learning is becoming no longer linear, but more of an aggregation mode, rather knowledge aggregation rather than a linear learning process. This is what we mean by aggregated process. You constantly have to learn through academic, constantly learn in a domain. You also have to constantly learn and practice disciplinary skills for system thinking and transformational skills. As a result, your knowledge, your experience, and people skills, the three dimensions of core capability at the individual level increases. So this is my final slide. Basically, what you're saying, sorry, let me go back here. So we said academic knowledge, industry sector education, and transformational skills are the three areas that you are interested in. Together, you can work on it. They are there all the time, whether you like it or not. So you can understand them, use it, or just ignore them and be a task-oriented, doing what you're asked to do. Or you become system-oriented and goal-oriented with a common language, core capability in three dimensions, and knowledge integration. Then you add to it emphasis on science or transformation and mobility of the data and end-to-end innovation. Then you focus on impact. And finally, you begin to add ecosystem and emotional intelligence. It becomes a sustainable methodology. This model is true whether it's for an individual, whether it's for a faculty or anybody in engineer in any company. It is true for an industry. It is true for AMTDC. It is true for a government. It's true for a country. Doesn't matter what it is. The methodology seems to work. Obviously, the scale and complexity will change depending upon the situation and the scale of the problem we are dealing with. But the beauty is the methodology is the same. See, at this point, I will stop presenting. Let me see how I can do that. So that, in essence, a very brief presentation. That also brings me to the philosophy. I won't go into the Vedic philosophy right now. But why I'm so excited about it is our Vedic philosophy also provides a very simple framework for how to manage life. That is the basis for emotional intelligence. We can talk about it another time. But if you think about it from a distance, system thinking and transformational skills essentially evolves from a fundamental belief that everyone participating in the system can contribute and can benefit from it. Then with that framework, we ask the question why. Then we ask the question what, related to the why. We ask the how, which is really the transformation of the science or the laws of nature. And another word for laws of nature universally in the Vedic philosophy is what we call Brahman. I don't want to go there right now because that will be too complicated and confusing. But let us stay with laws of nature. Understanding is that the science and implementation of that through aggregation of inputs whose complexity will depend upon the size and scope of the project. And that methodology codified through these 7 steps is what we call system thinking and transformational skills. So it has been very intense probably and very dense. I apologize for that. I have been always accused of giving a talk where it is too intense. That is my limitation. Forgive me for that. So I'll end up my talk with one story. This story involves a hot air balloon where there are 3 people in the balloon and they're flying in the balloon and they're coming close to somewhere, maybe near the Jamuna River in Delhi or the Adayar River near IIT Madras. And there are some interns working on the ground doing whatever they were doing. So one of the guys in the hot air balloon shouted and said, "Hey, can you tell us where we are?" The student, being very smart, said, "You are in the hot air balloon." And why are you? But another student who has learned this talk asked, "Why are you asking this question?" The other guy in the balloon got very mad and said, "What do you mean? We know where we are in the hot air balloon. Why do you care where we are? Just tell us where we are. Why am I asking this question? Just tell us where we are." So one of the students said, "You must be a scientist who asks the questions randomly without any purpose to it, just for the fun of it. Or you must be an engineer who forgot the navigational equipment and you didn't do what you're supposed to do, but now you're lost and now you're trying to fix the problem through a quick fix, asking, where am I? And panicking all over the place. Or you must be that guy in the pinstripe suit who got up there with a lot of hot air, who must be from the management rank, who is asking me why you are, because you got there with a lot of hot air, you don't know where you are, why you are, but now you are blaming me and calling me all kinds of names. So none of you are either a scientist, true engineer, or true manager, because we have been taught system thinking and transformational skills. So we are asked to ask the question why first before we do anything else. So please tell us why we are asking this question. Anyway, that's my story. It's a webinar, so I can't see your reaction, but nonetheless, that's where I end my seminar. Thank you very much.
Yeah, thank you, Dr. Subbu. I think Mr. Srikanth will moderate it, so we just want him to take the lead and then go ahead with the request for any questions. Srikanth, no? Yeah.
Yes, sir. Thank you, sir. It was certainly a very insightful talk on the topic of what really it is mean by system thinking and how it is going to be different than the routine task-oriented thinking and system thinking, how they are different. I certainly hope that many people would have started to have the awareness to do and then differentiate between the way currently we are having and then the way towards the system thinking. I now request anyone to open up and then share your views and thoughts or any doubts or questions that you have on this topic.
Good evening, Dr. Subbu. This is Nagalakshmi. Am I audible?
Good evening.
Yeah.
Yeah.
Good evening.
So I just want to know, can we really teach system thinking to somebody? Or is it like if they are working on some project, is it that through their experiences that they evolve out of it? Or is it like a curriculum where you are teaching them system thinking and their thought process changes?
It's a very good question. It can be taught. Like anything, any subject matter, if you understand it sufficiently enough, we should be able to put it together into some format, and then it can be taught. In fact, the framework I gave today will be like an introduction to system thinking and transformational skills. Then each one of the topics that I showed in the transformational skills can be taught as one section or one chapter. There is a book that is written on the subject. So if something can be written in a book, then hopefully it can also be taught to students. Now, just like any other topic, how much one practices or uses it in life depends upon the practitioner. For example, we teach finite element analysis in the college for static deflection and how to understand that. But how many people really use the finite element analysis in designing structures? Very few. Those who are really good at it do that. On the other hand, the need for system thinking and transformational skill is so pervasive that more number of people should be practicing it. So I will translate your question to say, yes, it can be taught. But if you ask me how many people will practice it, collectively we have to motivate more and more of the younger generation to practice that. I would say the same thing about Vedic philosophy too. With all the things that is written in the Vedic philosophy, so many scriptures, so many writings, how many of us really are at peace with ourselves? We go through so much panic and so much pressure and anxieties of life every day for every little thing, because he said this, she said that, or this what I heard, I don't like this. Why? Now, there are few people who feel better at it other than others. But again, education and methodology can help. So we can try. Where it will go, I cannot promise.
Okay, sir. Thank you.
Dr. Subramanian, can I just add a couple of things for that question, if you don't mind?
Yes, sir. By all means.
Yeah, my name is Mohan. System thinking or systems engineering it is very much taught in our most of the product companies in terms of there are certain standard practices like 3-view systems engineering, and there are some in-course which is recognized internationally to become a systems engineering training programs. Having said that, it's more of a certain principles, some approaches, the fundamentally how to think about it is being taught. But in order to build a system, for sure we need to have a domain knowledge, and we also always think about human factors as one of the aspects of it. So to be honest, we always look at operational aspects, maintenance aspects, architectural aspects, and then ultimately the user aspects. All these things are can be taught. At least we can train the people in order to think in those directions, so that the product which we are ultimately producing is actually resulting in ease of operation, maintenance, and successful what you call it's a cost-effective product in a cost-effective product. Also, especially when you are designing mission-critical systems, certain amount of graceful degradations, total system should not fail at one stroke. Similarly, how we can bring more MTBF, meantime between the failures, some amount of analysis is done. So there are many aspects in system thinking and system approach. Surely all these are to a large extent can be taught and made to practice while developing the system, so that you build a successful system. So I'll stop there, sir. Thank you.
Thank you very much. Very good observation, very good comment. As I said, the first thing the transformational skill is developing a common language. There is a lot of, if you go and do a Google search on system, you'll find so many different meanings. Then there is system engineering, system design, or design thinking, system thinking. So there are so many different terms. So we have to kind of classic, and all of them are useful, and I'm not saying any of them is not useful. So whereas we have to, system thinking may be more of a philosophic approach of how to approach anything that you're given, to move away from a task into a structured way of doing it, at system thinking. And also it has got certain requirements to be met. And of course, some of them can be codified, like the one that Mr. Mohan mentioned a few minutes ago. But as he's also said, most of the time, the system engineering and system approach in the industrial environment is largely focused on operational approaches. And also for people will repeat the same thing without error. And what we are saying is, how do you develop a new pathway, and how do you approach that with your own creativity, but giving a structure to your creative thinking? Thank you.
Thank you, sir.
So are there any more questions on the mentees or mentors?
Either it was totally clear or totally opaque.
Anyone else? Like, yes, sir.
Sorry, Dr. Subramanian. Again, in fact, I was interacting with some of the students. I wanted to tell you one thing. They have come out with solutions before understanding the problem itself. So first is they assume that there is a problem, okay, and they find a solution for that problem, and then they will tell a technology which need to be adopted for that solution. Everything is decided before understanding the actual problem at all. So that's where the problem of understanding a problem, understanding the users, understanding the technologies, understanding the what do you call alternatives, understanding the cost effectiveness. All these are not really thought over. It is more, okay, I want to use image processing for something. I want to use artificial intelligence for something. So the technology and the solutions are put before understanding a problem. So maybe would you like to throw something on that?
No, that's a very good question. Actually, that may be one of the biggest problems we are facing today in the area of digital technology. I'll give you another example, very related to what you were just mentioning, Mr. Mohan. I was talking to some engineers in a company in South India, very well-respected company, and they respect people and their work and making sure lifetime employment as one of the goals. So I asked this to an engineer, who is a young boy, what are you doing this project for? She said, I'm designing a robotic cell. Then I said, why are you designing this robotic cell? He did not understand robots can be for very reliable operation, reduce the errors, improve the operational efficiency of the other units around it, all kinds of good things that come with robotic automation. Instead, he said, it will eliminate 2 jobs, sir. That means 2 people will be eliminated. So that will be the cost savings for which I'm working on. I'm wondering if the CEO of that company had heard this and said this is why he's funding that robotics project, how much hurtful he would have felt in his own feeling, because that company, we all know, is very respected for taking good care of their own people. So this is true in every aspect of digital technology. People are talking about artificial intelligence as if artificial intelligence is an end in itself. But what is the true meaning of artificial intelligence? If it is capable of making us do things cheaper, faster, better, what you're already doing, that's one thing. Or creating new things that we could not even have thought of or are incapable of doing, that's another thing. Today, artificial intelligence is thought of as a way, everything you do with a paper and pencil, you write, you read, you understand, you comprehend. You take a book, artificial intelligence can do search and come back with certain report or the summary of the book faster than you can do by reading through it and understanding it. Is that what we want artificial intelligence for? See, you're absolutely right, sir. It is not only the students who are solving problems, because internship, we came to us, Professor Babu and I and others have had intense discussions on why should this be internship? Just because there's a funding resource and then the students to be trained, we just start an internship program. Our internship program is a vehicle for transforming a few students to think like the way you just mentioned, Mr. Mohan, to ask what is the problem, why do we do this, then what is the science behind it, how do we validate that before even spend a penny on that, what is the engineering behind that, how do we design that, and then how do we validate that. If students can be trained to do that, even a few of them, few hundred of them, that's a far more valuable internship program and useful people out of the coming to a company than simply starting an internship program simply because we got a solution for internship program. You're absolutely right.
So much. Thank you so much.
But I think we have a question from Kanchana Srinivas.
Yeah. Good evening, Dr. Subbu. Thank you so much for explaining systems thinking so clearly through a lucid storytelling approach. So when you say it so clearly, it seems so easy to apply. And if we were to put to practice what you've shared today, what is the one thing you would suggest we start to do from today so we may think in systems so that it becomes actually a practice of how we do it?
Excellent question, Kanchana. Now, I don't know if you're a faculty or a student or a professional, whatever it is, I'll address it at different levels. If you're a student, you should take the time to read. I'm not promoting my book because you can just read the summary of the book at Amazon, but you can read the book and so much in my website on system thinking and transformation skills. So you truly understand, along with this webinar, what the system thinking is, what are the transformational skills are. And then try to apply it in anything. A course I'm taking, why am I taking this course? What is it I'm learning out of that? What is the scientific nuggets out of it? How can I apply that? And what is the value out of applying that to something like that? Somewhere, and don't do it by yourself. Do it with your faculty, with some teacher or a mentor or something like that. Because you need some guidance, some coach, because you don't become good at these kinds of things overnight. So that's for the student level. At the faculty level, I would say start at the next level. That is, if you're teaching a course or teaching doing a project, take the same information, get the background out of it, and then put it through this kind of questions. Do I understand the common language? Do I understand the science behind the course? Otherwise, practical applications of that. Why is it important? Then build it up a little bit of time to see to it that course becomes very relevant and useful for more than just the students you are teaching in that course. Then you will find your expertise in that course itself becomes the seed to grow into a large innovation tree.
Okay.
And the same is true for any engineer working in any industry. Don't tomorrow you go to today is evening already in India. Tomorrow is weekend, also Sunday good. So then Monday when you go to work, you don't just go to job and sit at your desk and start doing what you did. Take anything you're doing, think about why you're doing this. Go sit down with your boss, have a heart-to-heart conversation with him or her. How will the boss be successful by doing this project? That will be the system output. How will the boss will be happy, which will be the company? How will the clients will be happy out of this project, which may be if you're on a manufacturing floor, it may be the next department, or it may be somebody else in the customer end, or the sales department, or the design department whom you are providing some service. How will they be happy based on the work you are doing? Define that first, and then do what you're going to do. You will be on the journey for system thinking. So
Super.
this is small, simple steps to start with.
Yeah. Yeah, ceramic springs indeed. Thank you, Doctor.
Yes, sir. Yes, ma'am.
Sir, we have a question from Sri N.K. Don.
Oh, my good friend Danji. How are you, sir?
Yeah.
You should be teaching this course. You are as good at it as anybody else.
Yes, sir. Ranji. Yeah.
Sir, you have to unmute to speak, sir.
Okay. I just want to add the answer that you have provided. Basically, I think one thing that anybody can start if you want to is the emotional intelligence part. Emotional intelligence part, which is most missing and most
Ranji, I think your audio is not very clear.
hello.
Ranji, I think your audio, it's not very clear. I don't know whether it is clear to the others or not.
Okay.
Yeah,
Okay. Is it clear now?
Yes, now it is clear. Yeah.
Yeah, I had not put down my microphone and my headphones, so I.
Yeah. Thank you. Yeah.
See, the emotional intelligence part that Dr. Subbu also mentioned, Sarve Bhavantu Sukhina, is one aspect. If you start thinking from tomorrow, for whatever you're going to do, whatever anybody at any level, if you think what I am going to do is going to be Sarve Bhavantu Sukhina, then I think the system thinking will start. That's my take on this.
I agree with you 100%, Danji. So in other words, emotional intelligence, which is another way of putting the same thing, starts with asking the question, what's the common language? Do I say what other people are understanding? Do I understand what other people are saying? That leads to then the question of why is it I'm doing this, the system output, the technical output, and how can we all understand the same thing based on the science behind it, on and on and on. Yeah, you're absolutely right. So these 8 transformational skills we talk about, they're not independent. They're like the systems of the human body. No one of them exists on its isolation, but they're interconnected. We can start with, as Danji said, have a philosophic outlook and then come down to the basics, or go from the basics to the philosophic outlook. But I agree with you.
Now, Dr. Subbu, I think I want to add my experience, on this system thinking, which I shared it with you, which I would like to share it with the others also. I think when I met him almost 12 to 13 years ago, when he told about the system thinking, I didn't know what it is, but then I was practicing it while teaching my courses. One day I asked him, this is how I teach the course, and you can also talk to our students and tell about the system thinking. Then he said that, okay, knowingly or unknowingly, people follow the system thinking. And the system thinking and Sarve Jano, Sukhno Bhavantu, they are closely related for the simple reason that if I'm thinking of the students, or if I'm thinking of my clients, if I'm thinking my administration and management, always that means I am trying to look beyond what I am and what I want to get it. I think that's where I felt very happy when I started listening to him and then understanding what is meant by this one. I think to answer the question of one of them like Kanchana, so in fact, this has helped us to put every thought into this sort of a system thinking framework, which enabled many students who graduated from IIT Madras as into a system thinkers, at least during their course of study. Whether they practice or not is left to those individuals. But however, once you just put a seed, as he said, that it grows into a plant over a period of time, I think I'm very thankful to him for introducing these concepts and asking our engineers to relentlessly follow that. But I am also not sure whether they have been able to really understand this well to teach others. I'm not still sure even after 10 years of interaction and then practicing it. But they'll be able to really bring out the structure and then say, this is how we do it. Hence, we fulfill these various inputs and outputs and technical and output, system output, etc. So that means, this is a process which you have to practice it continuously without, giving any break. I think it should become the way of life also. So that is my experience, in all these years. Thank you very much.
Thank
At
you,
the moment,
Ramesh.
I think, thanks.
Ramesh and Dr. Subbu, this is Rajan Rambabu. I just want to add my experience from Saudi Aramco, which is basically a Chevron-based American company. Basically, technology and systems are all used from them, even though it was in Saudi. There, every year we used to present our budget and the 5-year look ahead plan. When we present that 5-year look ahead plan, 5 years and 10 years also normally, there we used to submit a lot of proposals, which are basically, most of them are technical, because I'm talking of refining industry that time. And we used to put a lot of inputs there, okay, a lot of science, engineering, and what is benefits and returns and everything. But one day our director came back from head office, who is a Saudi basically, but studied and worked in America. And then he came and told us, see, you people are mechanical, process, electrical, and whatever disciplines. I am a different discipline. when you are presenting your proposal, please present in a system thinking. He gave us a simple clue. He said he has seen this when he was working in sometime in NASA also. 5 W's and 1 H. It starts with what, where, when, and who will benefit, what is the benefit, how to do it, what is the transformation value. We used to submit like internal rate of return or benefits and all. He says, okay, benefits you put it in a summary, but what transformation it is bringing to your department or your division and to the end product, or who is getting it, what is the benefit. In that way, he said 5 W's and 1 H. In this, you have to simply explain in one page because it is going through various levels. They are different fields. Sometimes they are not technical people, including the finance people, unless you put in a system way. Your engineering, your science, everything, you keep it in a simple way. Unless you put in a systems way, you cannot reach the people, those who are taking decisions to get it approved. And then only the transformation will take place based on your proposal or your project. That's what we are taught, and I used it almost for 10 years. Different. Sometimes we used to ask a lot of new technology items and everything, but by this method, we used to get less questions from the top management before its approval. And that is what I just want to share. The philosophy what Aramco is using, like 5 W's and 1 H, and in your presentation also you touched upon the process, how the system thinking works. Thank you very much, Dr. Subbu.
Thank you, sir. I appreciate it. Yeah, there are several, as Professor Babu was saying, and also Mr. Danji was saying, the system thinking is natural and implicit for all those who find the success in their own way. So the question is, what structure we give it? Whichever structure we use is okay. What is more important is not to fall trap for this plug and play solutions. The more you do what you're asked to do, and the more you become a plug and play player, the more you lose your prerogative and also your strength to use your thinking and your creative ability. You should not let that happen.
That is true.
Yeah.
Thank you, sir.
Are there any more questions?
I think it's really, time to wind up, I think.
Thank you, everyone.
Yeah, thank you, Dr. Subbu. I think it's really wonderful that you have spared your time to enlighten the students and others who have shown interest to listen to you. I think maybe we'll have some other time to have a detailed, sessions on what you have mentioned. I know that it will not be easy for anyone who's not following it to understand it. However, I think we will organize a few more as we go along. Okay. Yeah. Okay.
You're welcome.
Thank you, sir.
Thank you, everyone. Thank you, Mr. Prao.
Thank you. Thank you. Thank you.
Thank you, sir. Bye.
Thank
Thank
you.
you, sir. Yeah. Bye-bye.
Thank you, Dr. Subbu.
Yeah. Thank you.
So they went in.